Okay, this is your third out of what should be 5 different video segments you'll be watching to help you out with Chapter 6, 7, and 8 in the textbook. This is the second part of Chapter 7, which is over short truth tables. Long truth tables are a very mechanical operation. You set them up, you fill in the blocks, you know what to check, and it's not really something you have to usually think real hard about. Short truth tables require more thought, but they're enormously more efficient, and you can do things that would be really horrible to try to do if you're working on a long truth table. Let me just jump in here, and this is explained in the textbook, but I think if I show you this, it'll really help to understand what we're doing. Okay. Okay, let's say you have an argument that looks like this. A implies B, B implies C, C implies D, D implies E, E implies F. F implies G, conclusion G, and I ask you to test for validity. Well, you start counting. 1, 2, 3, 4, 5, 6, 7 letters. That's 2 times 2 times 2, 7 times. That's a lot of lines this truth table is going to take. And then you're thinking about it going, there has to be an easier way for this to happen rather than to generate this monstrous truth table. And you start to look at it and go, what am I trying to do? I'm looking for something. When I'm doing a truth table, this is both the long and the short. You're looking for what? True premises and a false conclusion. If I can find true premises and a false conclusion, then I know it's an invalid argument. If I cannot find that, then I know that it's a valid argument. Okay, well, let's think about it. I need to have a false conclusion, and here's the letter G. What does G have to be for me to have a false conclusion? See, what I'm doing here is true premises and a false conclusion. What do I have to do to G? G has to be false no matter what. If G is not false, then I'm not getting a false conclusion. And if G is false here, it's got to be false everywhere it shows up in the problem. Okay? I look at my first premise, which is the letter A. In order for that premise to be true, the letter A by itself has to be true. And so A is true in line 1, and G, because G is false, makes that G is working out to give me true premises and a false conclusion. If I can find a way to fill this in that's going to give me true premises and a false conclusion, that's fine. That's wonderful. That means I'm going to figure this whole thing out. So, I think a little further. If A is true, then B is something. I need for the whole thing to be true, and the premise is true, A. Does it matter what B is to give this whole thing a value of true? If you think back to Chapter 6, B has to be true, because if B is false, then the whole thing is false, and I want it to be true. I'm fighting to make it true. If B is true here, it's got to be true here. Now it goes quickly. If B is true here, B implies C, then C also has to be true. Click. C is true here, D has got to be true. Click. D is true here, E has got to be true. Click. E is true, that goes to F, which is true. Good, F is true. Now, right here at the bottom, F arrow G, true to false. That is not true. And what I have found, because I started with things that had to be done a certain way, is that I cannot make the premises true and the conclusion false. So this is a valid argument. Now, the test for validity for a short truth table consists of assigning values to the letters and determining if there's any way to make the premises true and the conclusion false. If it can't work out that way, if it blows up somewhere, then the whole thing is going to be valid. If I can assign values that make the premises true and the conclusion false, then it's invalid. This is psychologically kind of weird because you're looking for something, and if you find it, it's not a good thing. It's a problem. And so if you find a way to make the premises true and the conclusion false, then it is a invalid argument. Is everybody going crazy yet? Let's try a few of these because it doesn't take long to do the short truth tables. When I grade your short truth tables, I have to have you determining validity or invalidity. I have to see you assigning values in a way that makes some kind of sense. So let's look at several problems that are kind of similar in form. And if you can figure out how all this stuff works, you've really got the nuts and bolts figured out for a long truth table. And these are similar. I just use the ands here, the ors here, and the if-thens here. Problem 1. In all of these cases, I want to make my premises true and my conclusion false. That's what I'm trying to do. If I look at my conclusion and I need to make an and statement false, there's 3 ways to do that. True and false, false and true, false and false are all false. I do not want to start with something that's iffy. I want to start with necessity. If I look at premise 1, A and B, there's only one way to make that premise true. The whole thing is only true when both parts of it are true. Check. If B is true here, it's true here. If A is true here, it's true here. I go to the next premise. B is true and something for C. What does C have to be so that the whole thing is true? Well, it's an and statement. So B and C both have to be true. And if C is true here, it's true down here. All I have left to do is to read this bottom line, A and C, true and true, but that's not false, that's true. So the long and short of it is I cannot make the premises true and the conclusion false. So it is a valid argument. It's valid because it blows up. And yes, I know that's a little bit strange. You can do long truth tables for all of these, and that'll actually maybe give you a little bit more insight as to what's going on. If I look at the top here for the next problem set, A or B, B or C, conclusion A or C, if I want to make this true, there are 3 ways to make an or statement true. True or true, true or false, false or true. Because that's iffy, I don't want to start here or start here. I want to start in my conclusion. I have a statement that has to be false. A or C has to be false. The only way to make an or statement false is to make both parts of it false. And as I said before, you've really got to have that chapter 6 stuff down very, very well before you move to this. Because I should be able to say for you, in order for an or statement to be false, both parts have to be false, and that should be kind of obvious to you. If A is false here, it's false up here. If C is false here, it's false here. I look to my first premise now. I want to make the whole thing true. Is there a value I can give to B that will make the whole thing true? And if I think about it, if I make B true, then the whole thing works. False or true is true. If B is true up here, it's got to be true here. I've got true or false is true. So with an assignment of A is false, B is true, C is false, my first premise is all true. Second premise true, conclusion false. That's what I'm looking for. And now I have to say of all things that this is an invalid argument. I know that thing right there is confusing. And all I can say for you is that's just how it works. Get used to it. If it blows up, it's valid. If it works out, it's invalid. And so there's a little pause while you try to figure it out. Now I look down at the third problem. A implies B, B implies C, A implies C. I want to make my premises true and my conclusion false. There's 3 ways to make that true. True to true, false to true, false to false. I cannot begin here, I cannot begin here, I have to begin at the bottom. Because to make A arrow C false, there's only one way to do that. A has to be true and C has to be false. And again, if I'm going kind of fast for you, that's why you've got this thing on video. Go back and start over. If A is true here, it's true here. If C is true here, or false here, excuse me, it's got to be false here. Now, is there a value I can assign to B that's going to make this work out? If I look at this and go, okay, I need to make this true. A, arrow B, does it matter what B is for A, arrow B? Well, if A is true, B has to be true. If B is true here, it's true here, but B implies C, true implies false. That's false. I cannot do anything to make that true, so it blows up. So that's a valid argument. If it blows up, it's a valid argument. If it does not blow up, it's an invalid argument. Once again, I have a question of where to start this thing. I have arrows at the top and an or at the bottom. In the textbook, I explained to you there's actually a good shortcut for figuring out where to start these things. There has to be a line in the problem that marks the difference between the premises and the conclusion. Remember that I'm trying to make the premises all true and the conclusion false. In the top, if I have an and or a single value, I can make them true very easily. In the bottom, if I have a single value, an or an if-then, I can make them false easily. By single value, I mean something like the letter P or not P. That is, a letter by itself or a letter that's just negated, because it's easy either way. Now, if I look at this problem, I can start where? This is where you start to do your solution. And single value, or if-then. I have if-thens above the line, so I can't start there. But I have an or below the line, and the reason I have that on my list is because there's only one way to make that false. I have to make both parts of this false to make the whole thing come out as false. Now, in a problem like this, the rest of it becomes easy because these letters just move upstairs. So L is false, and K is false, and K is false, and L is false. I don't have any choices. I do, however, have to check them out. False, arrow false is true, so we're good. Not false implies not false is the same thing as true implies true. Not false is true, not false is true, true implies true is true. So this all checks out. This is an invalid argument. Again, I know that's strange. If it checks out, it's invalid. That's how it works. Once again, I have a bunch of arrows here. The only place to start a problem with this many arrows is in the bottom. Not C is going to give us A. Okay? The only way to make an arrow false is to the left side true and the right side false. To make the right side false, I make A false. To make the left side true, I need to make C false. Not false is true. True arrow false is false. Now, when I've got negations, I try to make sure that when I put the little T or an F here, the T or F just stands for what the letter is. So here the letter F goes to the A. That's actually going to be not A, not false, which is true. Here, this letter C is false, not false, but here it's just false. Now I have to think about the problem to decide if there's any way to make it work out. Here, I have in premise 2, false arrow something. If you check your chart, false arrow true is true, false arrow false is true, and so it doesn't matter what B is here in line 2. I'm going to move up to line 1 since line 2 doesn't matter. Not false implies something. I want to make it true, and what I have on the left-hand side is true arrow something. What has to go to the right-hand side is true. True arrow true is true, but true arrow false is false. I want this to have true premises and a false conclusion. So, not A, not false is true. True arrow what? Well, this whole thing has to be true. In order to make not B true, I have to make B false. So B's got to be false, and that checks out. False arrow false checks out. Not false arrow false checks out. So this is true, this is true, this is false. If I assign those values, because it all works out, this is an invalid argument because it does not blow up. That is, by working at it, I find a way to make the premises true and the conclusion false. I'm going to look in the book for a couple of problems here, just so you can follow along with the way that the book problems work. So let's look at problem 4 on problem set 7.5. One of the things you'll notice right away about this is that you've got single values here in 2 places. Those are always a joy. Because if I'm going to make the premises true and the conclusion false, they set up very nicely. To make the conclusion of F false, I have to make F false. And it's false here. To make this not D true, I have to make D false as well, because not false is true, and D is going to be false here. Once again, if I have false arrow something, it doesn't matter to me what's on the right-hand side, so I skip that and go down 1. In line 3, E or F, F is false. To make the whole thing true, the left-hand side has to be true. True or false is true, check. I take that value of true and I move it up. False arrow true, it's true, good. And so this is an invalid argument. If I do problem 5 on set 7.5, what I've got is not G or H, not G and I, conclusion I. It doesn't take a lot to see where you start this problem if I want to make my premises true and my conclusion false. I've got a single value here, and the rest of that's rather complicated. This will take some thought. As I said, it's not as mechanical when you're doing it this way. It involves some more thought. So, if my conclusion is I and I want I to be false, I just say, hey, I's got to be false. Sounds like Popeye. I's got to be false. Now I go up to line 2 because that's where I've got some information to get a little traction here. I want to make the whole thing true, but it's going to be negated, which means that the thing inside has to be false. G or I. Well, no matter what I do to G, because of the I being false, this whole thing's going to be false, and that's going to be true. So G doesn't matter. And I'm now going to use that line of reasoning up on I. True. I want to make this whole thing true, but it's in parentheses and negated, so what's inside has to be false. True, but it's got to be inside false. That's an OR statement. To make an OR statement false, I have to make both sides of it false. Not false is true, good. G is false. And now I double check this. False and false is false, not false is true. Life is good. And this becomes yet another invalid argument. Again, what I'd suggest you do is to put these problems to one side and come back to them 12 hours or a day later and see if you can start to remember some of the reasoning that's being used here. Problem 6 gets to look a little scary, but it's not that bad. And the reason 6 isn't that bad is because you have the presence of the and in it. And the presence of the and makes it relatively easy. So, J or K or L, not J and not L, conclusion K. Now, I want to make my premises true and my conclusion false. I've got an and statement above the line. Remember this chart? An and or a single value above the line is good. A single value, an or an if then below the line is a good place to start. So below the line, I've got a single value of K. I'll just say that K is false and life is good. Here, I've got an and statement. For the and to be true, both sides have to be true. In order for not J to be true, J has to be false and L has to be false. Not false and not false. True and true is true. So J is false and L is false. Now I've got J or K, false or L, which is also false. False or false is false. This is like what we did in chapter 6. False or false is false. We pull up that value of false or false is false. And I cannot make this, because it has to be now a false statement. I cannot make this true. And so it's a valid argument. That's what you're looking at when you're doing the short truth tables. Once again, when you're working through the book, you've got to make sure that you've got the long truth tables down, because even though it doesn't feel like it, the proof that you are doing here, this test for validity that you're doing, is the same test you did with the long truth tables. Probably the best way to do that is to show you the short truth table and then how the long truth table compares to it. It works best when the argument is one which is invalid. And the only problem with this one is that there's no good place to start it for the short truth table. So let's just give you a little something to hold on to and call this not y. And that's going to make it a little easier. So let's do this as a long truth table then. Not y, x or y implies z, x or z, x and z. Okay? So X, Y, and Z. This is, again, an 8-line truth table. 4 trues, 4 falses, 2 trues, 2 falses, true, false, true, false. We need not Y, that's our first premise. We need X or Y, which is our second premise. Y implies Z is our third premise. X and Z is our conclusion. We negate Y. Y is T, T, F, F, so it's F, F, T, T, F, F, T, T, just the opposite of Y. X or Y is only false in the last two, so it's T, 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 F, F. Because X or Y, it's true if any part of it is true, and it's false when the whole thing is false, which is down in 7 and 8. Y implies Z. Here's Y and here's Z. It's an implication, so it's only false when true goes to false. True to true is true. True to false is false. False to true is true. False to false is true. True to true is true. True to false is false. False to true is true. False to false is true. And that's your premises. I check to see which of them have all true premises, and that's in lines 3 and 4. My conclusion is X and Z. X and Z. They're both true here. One of them's false here. They're both true here. One of them's false here. One of them's false here. Both of them are false here. One of them's false here. And both of them are false here. So TF, TF, and then 4 F's in a row. I do my test for validity. True premises, true conclusion. Keep looking. True premises, false conclusion. And this is where I find out that it is an invalid argument. So that's just a nice little bit of review for the long truth table. Now, when I do this as a short truth table, I have to start somewhere, and I start with my single value. My single value is not Y. That means that Y has to be false. Not false is true. Check. So Y has got to be false in all of these. In line 3, I've got false leads to something, but that doesn't really matter what it leads to. Either true or false works. So I go back up to here. X or Y, something or false gets to be true. I have to make X true here. I have to make X true in line 2. X is true down here. Okay? I go to my conclusion now because that's where my data is leading me. X and Z. I want the whole thing to be false. Can I do anything to Z that makes the whole thing false? And the answer is sure. If Z is false, then the AND statement fails. We're good. And now I move this up here. Y, arrow, Z, false, arrow, false is good. I have found a way to make the premises true and the conclusion false, and that is also invalid. So, it's invalid by this test, and it's invalid by this test. By the way, if you want to, when you're doing your final, you can sit down there and plot all this stuff out. Now, you can do it both ways. Even if I'm asking you for a long truth table, you can do a short truth table by the side most of the time. Now, if this is invalid and this is invalid, what was the point? Well, if you go down here in line 4, this is where the whole thing ended up being invalid. In line 4, you have true premises and a false conclusion. Under line 4, X was true, Y was false, Z was false. Okay? True, false, false. If I look up here, look at what happened. I almost think I know what I'm talking about here. X is true here. Well, goodness gracious, X is true up here. Y is false. Y is false. Z is false. Z is false. If X is true, Y is false, and Z is false, then it's invalid. If X is true, Y is false, and Z is false, it's invalid. What we're doing in a short truth table is looking for this, but we're doing it in a much more efficient manner. Now, there is no reason there has to be a good starting point to the arguments. For test purposes, I will try very carefully to make sure that the questions you have over the short truth tables always have a good starting point. That's why when I generated this, I had to add that premise to the top, otherwise there was no good place to begin it. This still would have made sense, ultimately, logically, but by doing it this way, you have a way to get into it so that it's soluble. If you got really tricky, you'd have to start saying, well, this might be true and this might be false, and taking a lot of guesses. Ultimately, follow this procedure, memorize this. This is a great thing to put in the margin. And single value or if then. And what does this mean? There's your line that marks the premises versus the conclusion. And this is where you can start your short truth table. When you get to the point of deciding whether to label it as valid or invalid, double think on a short truth table. Even though it's the same test as the long truth table, it feels kind of natural in a long truth table, and it does not all feel natural when you're dealing with a short truth table. So I would ask you just to be very cautious about that when you get to that point in your analysis. Go through, double check it, and make sure that you're doing the right thing and compare it to what you did with the long truth table. Other than that, this is an awful lot faster. I do, though, need to see assignment. One of the things I sometimes show people to do is over to the side. Remember, okay, X, Y, Z. X is true, Y is false, Z is false. There we go. There are, by the way, you will see this in the book, sometimes problems where ultimately say the value of Z doesn't matter. At that point, you can call it true, you can call it false, or you might just be cute and put a question mark there because it doesn't really matter. That will happen occasionally. But usually what I'm doing here, it matters all the way through. Okay? So this is going to be the end of your third video, 7B, and we will stop the tape and then get rolling on the 2 videos for Chapter 8.